All right, I see it is officially 11, so we can kick off. And good morning, everyone. Happy Friday. I hope you've had a great week thus far. If not, if you're here in South Africa, you probably have a long weekend ahead, probably took Monday off, so always a good thing to look forward to. Wherever else you are tuning in from the entire world, welcome. And today we're going to be looking at preliminary design for roads, a BIM and GIS solution. So today's session is going to be presented by myself. I am Shuaib Yunos. I'm the BIM Technical Specialist for Civil Infrastructure and Mining here at Baker Baines in South Africa. I hold a BTech degree in Civil Engineering, being a qualified Civil Design Technologist. And in conjunction with that, I am a Civil Consultant, Autodesk Certified Instructor, as well as the Champion of BIM for Civil Infrastructure here in South Africa, and abroad. A few things that I do enjoy is, of course, the beach, growing up on the south coast in the KwaZulu-Natal, deep sea fishing, powerlifting, as well as archery, which is always fun. So a little bit about us here at Baker Baines. We specialize in 4 main segments, as you can see on your screen. So survey and design hardware consultancy, design software, business process improvement and consulting, which is the major part of what we do. And of course, we apply a blended learning approach, being a blended learning provider. Now, what does that mean? I think logos are always much more better to summarize things. So from a scan to BIM services perspective, we partner with Topcon as well as Leica. So if you're on the construction side or on the mining segment, you would go for Topcon because they are catered for that environment. And if you're more architectural or interior or buildings types of designs, you would definitely look at Leica, being the BLK 360 or something like that. In terms of other amazing technologies that we partner with, if you've seen my last webinar series, I talked quite a bit about IDAS. It stands for Infrastructure Design Automation Suite, developed by the Devitin Group of companies. It is an amazing tool and a must-have by any civil design professional that's working in civil 3D. It makes it much more better, much more robust, much more of a BIM platform when it comes to automated road design, as well as pipe networks, being water, stormwater, sewer, and bulk water. So it's a very, very powerful tool, and it is localized to our South African standards and norms. If you're looking more on the point cloud portion of things, we can look at ClearEdge 3D. What it does is it has automated geometry point cloud extraction features, meaning that it will automatically extract the geometry into a CAD format for you from your point cloud, saving you about 70 to 75% of time, if not more, and it is a game changer in the scan to BIM workflow. We as a company are very fully fledged in the consulting methodology of things, and we are very proud to be a BBBE level 1 contributor in South Africa, as well as being listed at Autodesk as a service provider select, as well as featuring on the services marketplace as a provider. Last but not least on the slide is we provide classroom and virtual training, virtual being the norm according to our circumstances at the moment. So we are an Autodesk certified training center, and we promote, or we're the reseller for AutoCAD as well as CAD learning, which is a blended learning approach here in South Africa. So if you want to learn on the go and you've got a lot of different software that you would need to upskill on, be it Civil 3D, be it AutoCAD, Inventor, Revit, 3ds Max, Advanced Steel, and the list goes on. It is all on our CAD learning platform, where you can log in, where there are pre-recorded videos, classes, tutorials, step-by-step to help you learn on the go, as well as upskill yourself to be a better, fully fledged civil designer or architect or anyone in the AEC or PDM industries. And if you are more segment focused, we cater for the following segments below. So building, civil, structural, energy, process plants, and manufacturing. All right, so now that we got that done and dusted, let's look at today's session. What are we going to be focusing at and what does it entail? So first of all, we're going to give context. So many of you have attended previous webinars that I've hosted. I always like to paint a picture and put it into context. So from feasibility to preliminary design for roads, what exactly does it entail? We're going to look at what it looks like and what we need from it. And then we're going to jump directly into the topic at hand, being the proposed solution being BIM and GIS. And you're going to see exactly why we promote this type of a workflow. And then we're going to jump directly into the stages that you would apply in the preliminary design for roads workflow. Just a quick fly through. You can see we've got quite a bit on feasibility, planning, BIM for roads, bridges, tunnels, drainage, and so on. And then, of course, I've added two more segments, being the collaboration part. So working together wherever you are. And of course, always the coolest part of most of these webinars is the visualization aspect. Getting your vision across in a highly visual manner. And if you have been following us on social media, you should have known that previously or recently rather, we had published a customer success story from one of our clients, HHO Consulting Engineers here in South Africa, where they realized the value of visualization plays in a highly technical project, or if you need to convey your message in a simplistic way to those that are not of a technical nature. So very, very cool. If you haven't checked it out, head over to our social media. We are posted all over. It's a really, really fantastic story. And last but not least, we're going to close and wrap up with our conclusion, how we can help you, and of course, our Q&A. So during the presentation, if anything pops into your mind or you would like to know something, drop it into the chat box, fire away, and I will get to it at the end. All right, great. So let's go to the first segment, from feasibility to preliminary design for roads. What does it entail exactly? So I've broken it up into a very simplistic manner and hopefully that you could relate to. So let's start off with the description. So what does this entail? What is it described as normally? So first of all, you would need to evaluate the terrain along the existing proposed road. I mean, that is a given. However, it's not as easy as it sounds. It can get very, very complex when you have a lot of socio-economic development around it as well that are impacting on it. This leads us also to desktop studies. So again, exactly what I've just said, socio-economic and environmental restrictions or additions depending on what you're going to be providing. We would need to also explore the site, see exactly what's around there, what it links to, what will impact it in a positive way, what could be more sustainable, those type of things. And then, of course, when it comes to legislation, we cannot overlook it as engineers. Of course, you need to look at the lawful use of the site. Okay, so you're going to be more contract-based as well as consult in terms of extent of land, encroachment, those type of things, and some type of course, expropriation. So that is more or less what it is described as. When we look at the outcomes, what exactly are the outcomes of a feasibility study? I've spoken to many professionals in the same field. Yes, they do know what it entails, but they can't really decipher what do you need to get out of it. So I have again broke it down into very, very minimal content. So first of all, you need to establish the socio-economic activities, meaning that you need to find out how your infrastructure is going to be fitting into in urbanization, we call it nodes and all of those type of things, corridor activities, those type of things. So you need to see how it's going to plug and play and how it's going to boost this and have a positive impact in those socio-economic development type of things. Environmental, of course, environment is always key. We need to have as least impact on the environment, and where we do have a very strong impact, we need to rehabilitate it as much as possible. Operational, is it going to be functional? Is it going to be too out of reach? Is it going to fulfill its requirements? All of those type of things you need to bring it down to the finer detail so that everything clicks into place when we get to the prelim and then up to detail and final design. Very, very important thing here, right? If you're in the city, you should know projected traffic. Traffic is increasing everywhere. It's not only in Joburg, it's not only in Cape Town, it's everywhere right now, because with the rapid urbanization, acceleration of people moving to cities, we are going to be getting more private ownership of cars, we're going to need more transport requirements, all of those type of things. So looking at the projections that you would need, your lane distribution factors, growth factors, population, all those type of things, you're going to need to incorporate that into your feasibility and see, okay, by maybe a 10-year, 20-year, 50-year period, or maybe the design life of the road is 20% or rather 20 years, apologize for that, you can actually need to project the traffic and see that the road is catered for and it's not elapsed its design functionality. So very, very important when it comes to transportation is actual traffic. And of course, this is all underpinned by our standards that we would use both nationally and internationally. If you're working, everything has to be in compliance. Those design standards, those specs are there for a reason. We need to respect them. Okay, so we've got the description of the activity, we've got what outcomes are needed. What are the challenges? So the challenges, of course, this is the most common one from all of my design experience, over-reliance on sometimes outdated data. I could really want to replace that word sometimes to most of the time, unfortunately, but you would see sometimes you're working off very outdated topographic data, aerial data. Sometimes you might do the design, it might be in a remote location. I've had this experience where I did a project in the Eastern Cape and I planted my road, I had my corridors done, everything was good. This was in the prelim stage and I had an opportunity to visit the site just before we pitch it as a design. And lo and behold, when I go there, there were a lot of stuff that was not reflected on my topographic data. So there were huts, there were houses, there were a lot of other structures that were going through my road, to be quite frank. So this is a very, very hectic challenge, and it's a challenge that is repeated irrespective of which industry you're in. Transitioning, definitely. So if you manage to find the data and it is of relevance, it's up to date, how do you translate it so that you use efficient methods to correlate it between planning right up to preliminary design? I say prelim because today's topic is up to prelim, but if you look at the methodology, if you apply your logic to it, you can actually apply it to the entire project. Inaccuracy, time consuming, I mean, that is a given. I'm not going to explain that. And a very important one is under or overestimation. When it comes to land use itself, so you might, if you're doing maybe a clover leaf or something like that, you could probably size it a bit too big, so you could be wasting land, to put it quite frank, or it could be too costly or over cost. Sometimes, or the worst project is when it is under cost and you need to deliver. It's a very, very painful process to be in, and it all affects your economic viability at the end of the day. So now that we understand what a feasibility study is, what is required of it, and what are the challenges, let's look at now taking that data to the planning, concept, and prelim stage of road design. I've grouped this together because they literally click very, very well and they overlap at this stage. The challenging part being feasibility or desktop, bringing that data in here, what does it consider? So again, summarize it very, very in small tidbits. The description will be, of course, you will need the design of a roadway to a decent level. Now, if you're a designer, you will know what that level of decency, if I could call it, will be. It has to have that required level of data that you can actually make an informed decision at the prelim design stage. You will then agree on the road configuration. So you need to decide, okay, depending on the socio-economic development or activities, the road corridors, the sprawling, all of the urbanization factors that you would normally feature, or encounter during a project, especially in the city or urban areas, you will need to take that and factor in to decide how many lanes are you going to be using, the widths, the distribution factors, all of those type of things, as well as the class, right? And then of course, these form the basis of the detailed design. So the better homework or the better insight that you get at this stage, it has a domino effect as you're progressing towards the roads project cycle. So that's the very, very simple description that I can give you of this stage. When it comes to the actual outcomes, we've got geometric design. You need to lock in a design and make a decision. You need to configure your road in terms of class from a pavement standpoint, use your GRH4 or decide on your pavement configuration. You would need a fairly decent, close to accurate, or if not as accurate as possible, estimate of what it's going to cost. So you will use your BOQ, your bill of quantities, and all of the associated legislation or quota, whatever you want to use. And that will be your three basic or main outcomes. Now, what challenges are faced here? First of all, you will see challenges that are faced at the beginning relate throughout the entire project. It has a ripple effect, a negative one in this case, where outdated data still finds its way in the prelim stage. So previously, the challenges that I've mentioned, I've just left them out, but they are included in here. I've added some additional ones being leveraging the data. So sometimes you might have the data, but you might not be able to use it, or you might not have the application to use it or the expertise to use it. And the worst one I would say is the manual time-consuming process that's normally associated to data collection at this phase, because you might do something, let's say on a non-dynamic tool. I'm not shooting down Google Earth. We've all used it quite a bit in consulting before other technologies arrived. But if you're doing a design or a profile on Google Earth using the conventional technologies or functions that they have, you can't translate that into a design model. You would get an idea, but that is it. That's why I say you are basically starting from zero at this stage. You will still have to wait for survey data. You will still need all of the other relative factors that you would incorporate at this stage and then start your drawing. So it's already putting you at a back foot. Again, costing is always an issue. If the data at the beginning is bad, the costing is pretty much going to be the same reflection of that. Non-dynamic means of design, meaning that there's no interlink, there's no dynamic, it's more or less static, meaning that there's no live relationship between what you're doing versus the surrounding environment, i.e. contextualization of design. So that is it. Okay, so now you've got an idea of the picture and the challenges that we're facing. Let's look at the solution itself. I mean, why do we propose BIM and GIS? So let me give you a small breakdown so you can agree with me, hopefully. I am clearly biased on this end, but I'm pretty confident at the end of this webinar, you will be on my side as well. Okay, so BIM, why BIM and GIS? If you look at the infographic on the right-hand side, we've got Esri and Autodesk, Esri being the leader in geospatial data, and Autodesk being the leader in building information modeling tools. Now, BIM is information repurposed from design data and can be a great source of information, meaning that you will use it for ongoing operations and maintenance of an infrastructure. This could be anything, so the drawings that you would submit, i.e. your as-built data, that is very important in the O&Ms of any type of infrastructure. Now, where does the GIS part come in? Geographic Information Systems. So typically, the information needed in the context of buildings, infrastructure, and stuff like that, they actually comprise or contribute to a greater or entire system, and that system is GIS. That is literally it. You're going to take the live data, bring it in with the capitalistic data, and you're going to link it in. If that still doesn't make sense, I'm going to break it down a bit further. So let me just switch slides here. Here we go. What is possible if you do leverage this in the correct, intelligent manner? Digital twinning and smart cities. Okay, it forms the basis of this. So if you could link in your geographic information systems, your reality capture, your building information modeling technologies, as well as your IoT, your Internet of Things, where we're taking that smart integration, linking it to a BIM model, and also taking into consideration the live data that is surrounding that infrastructure, being GIS. So you can see it goes right from planning to analysis, sustainability, visualization, and if not sometimes other being some special cases which you would encounter. So it's a very powerful, positive thing if we all want to endeavor towards pursuing smart cities and smart infrastructure. And last but not least, I think this will put it pretty much in context, where capital projects are being the design itself, the BIM type of environment. You've got the building. There, of course, the capital portfolios will be more or less your GIS information. So in a nutshell, GIS informs BIM and BIM fuels GIS. So it's like a win-win. I mean, you've got the building living off the surrounding data and you've got the data feeding in back to the sustainability of the actual building. All right, so I hope that that explanation has put things into clear context for everybody. Now what we're going to do is we're going to jump into the workflow. So let's have a quick fly through using BIM and GIS as a workflow. We're going to start from feasibility right up to prelim road design. Now this is the skeleton view, I would like to call it that, of what's actually going to happen, where you would have your data analysis here and field data, in other words, your data collection and collation, and you will take that in and you would link it into your ArcGIS platform. Now, if you're on the desktop, of course, you will use Arcgis Pro, which is desktop-based. You will then need to select that data, publish it to ArcGIS Online, where it can be viewed via desktop, web, mobile. Thereafter, you can either set level of access depending on professional use. But what we are very interested in is the link between getting that data, publishing it to the cloud, and linking it into our BIM model. Now you can see here, InfraWorks is mentioned specifically because it is the place to go for planning and concept design. It's very visual, it's very easy to use, and from there it can be linked to detailed design tools, Civil 3D, Revit, and so on. So this is the part that we're looking at. Now, if you had to assign that to a more methodological approach, this is what we're looking at. So first of all, in the feasibility study, we need to check the land use, we need to propose a corridor, we need to see if anything needs to be relocated, the social impact it might have, and concerns that might be raised, and of course, environmental. Environmental, of course, the critical part being the avoidance zones and conservations. These more or less shape or can govern the direction of the road and what it has to bypass. So that's very important. Now, if these factors cannot be established, as mentioned previously, you can have a tough time going forward right into prelim. Survey, of course, we have many methods now to actually capture that data. So you would need that topographic data at a high precision and bring it into your design models. You can also introduce innovation by using laser scanning, i.e. UAVs or drones as they are known. Then after, once we have that data, we're going to bring it into the planning and concept stage where we're going to pull in all the data. We're going to use parametric designs to develop our roads, bridges, drainage, in some cases tunnels. And then of course, we're going to evaluate design alternatives. Now this can be done in InfraWorks, where you could use proposals. I've shown this in my previous webinars. They are on our YouTube channel, but I will give you the details at the end. Right, so you've got that. You can also optimize when needed, and then you need to portray and present your design in a visual manner. This is a very complex thing, or it's a very tough task at the moment from a lot of consultants that I've been dealing with, where the design is technically sound, they understand what they're doing, it's compliant, it meets the specs, all those type of things. But the people that you're working with, the consortium, the professionals, and even the clients sometimes who could probably be just as a means of capital, they do not understand the technical nature. So you will need to, in simple words, paint the picture, the pretty picture in front of them so that they can make comments and you could address them. Last but not least, this is a very smooth transition between these two generally, where you would take that data, link it into a dynamic 3D interface, perform contextualized modeling or rule-based design depending on the design speed of the road, those type of things, reflect the changes dynamically, collaborate multidisciplinary, and provide centralized access. Now we're going to go through all of these things today. So sit tight, just understand the methodology. If you get that in mind, the process itself is quite easy. So if it looks a bit daunting, fear not, we are here, we will take you through it. Okay, so let's start off with feasibility societies for the roads using GIS. So this is what we are proposing, where you would set an origin point and a destination point. You will include certain parameters that you feel will impact it. As an engineer, we all know slope being the terrain. So you will take the slope. You will also take the land parcels that it passes through, property development, land value, those type of things. You will incorporate that as well as the environment. Of course, the greater the slope, the greater the cut and fill, the greater the cost. So you need to apply your logic here as a designer, okay? That doesn't go out the window with software. I mean, it has made our lives very, very easy, but we still need to apply that. But you're going to see now how we're going to use this to actually select an optimal route, or as we've been calling it, route optioneering. So let's get into it. So first we're going to look at using the Arcgis Pro, which is on the desktop. And we're going to look at the interface, how it looks, and how we're going to create a project for the feasibility study. So let's jump in here. So as you can see, this is the interface of the actual desktop. You've got all of the data that's associated or linked to on the left. Of course, you would need, that can be public data, or you would need to purchase it from a provider. Okay, we've got a DEM and we've got a land use map, so we can toggle that on and off. As you can see, now it'll bring in all of the land usages. The DEM being a very critical part. You've got the destination and origin points. So if I had to zoom in here a little bit, you can see that circle is our origin point. So we're telling the software that, hey, listen, our road needs to start somewhere here. And if I scroll up a bit, the triangular portion, that's where it needs to end. Now, bear in mind, we have not drawn the road. We have just set the start points of the road as well as the end point. And we're telling the software, hey, we need help in you connecting us from A to B. We don't have a defined path. Can you propose one for us? On the right-hand side, I can then go to my projects. You can see all of that databases have been linked in there that you've seen. And under my project, I can add a proposal for the feasibility study. So this is where I will say new tool set, and I can give it a name. So we can call it feasibility study. So just type that in very quickly, very slowly. Actually, let's make it more specific. We will say road, right? So we don't get confused. Feasibility studies are very incorporate or inclusive of a lot of infrastructure. Now what we'll do is we'll create a new model. And as you can see here, it is blank. And this takes us now to our next step. So the next step will be in adding analysis parameters. So the things that I've mentioned to you previously, where you would need to take into consideration the slope or the fall or the rise of the terrain relative to your origin and destination points, as well as maybe the environmental impacts and as well as the land value or cost. So let's look at how we're going to do that. So I'm going to skim through this video. I will leave so that you would get the idea, because the process is more or less repetitive on what you're going to be adding. But let's go through this fairly slowly because it's fairly new to most people. So in the first place, what we'll do is in the model properties, we'll give it a name. A common mistake made here is under the name itself, it does not allow spaces. So for InfoWorks users, you know, normally the proposals, you can't make any spaces. You would normally use an underscore or do what I'm doing right here, same story, right? So if you are related to Autodesk software, think of this as a proposal that we're doing right now. Now, a very important thing or really cool thing that's built into Arcgis Pro is the tools functionality. So if we go to the top here, On the right hand side, these are all of the tools that you can actually leverage and make use of in a very quick manner. Simply dragging and dropping, right? Like taking a sub-assembly and dropping into your drawing, or how you would take data from different sources and drop it into InfraWorks. It's the exact same thing. So you can see we've got spatial statistics tools, right? But the one that I'm actually interested in at the moment is the actual surface. So let me look at, there we go. So we can expand surface and we can bring this will read from the metadata that has been incorporated in the GIS data. So we'll drag and drop, let's just try that again. Okay, I think because we dragged it twice, we can actually delete one. So let's just delete one. Okay, so if I wanted to set the parameters, I could always double click on where it says slope. Now it's going to be asking you for an input raster, meaning that what data do you want to reference from? Where do I get the slope and all of the geospatial data from? It's going to be our DEM. DEM standing for Digital Elevation Model. So I'm going to select that, and you can see the metadata it reads from directly is slope underscore DEM1. So it will give that in, and it will also show you the file path as to where that data will be saved. If I wanted to add any other aspects, for example, if I go to environments, I can input an output coordinate system. I'll come back to that just now, but I can also decide the cell size being maximum. Normally, we can convert the units if there's a conversion needed. And that also relates to the output coordinate system. If you need to create a coordinate transformation, you can actually do that in ArcGIS. Not only that, it will show you the file path where it is saving this metadata. So for example, if I hover over here, it will give you the user access, the project work file, and that's where your data is going to be saved. So if I click OK here, you should see now it has drawn like a process for me. Okay, so it's analyzing the DIM, output is going to be slope, and the result is going to be from slope underscore DEM1. Now I can also rename this if needed, okay, and I can also run them all together, but I'm going to just run an analysis on the slope icon or square or rectangle, whatever you want to call it, right? The yellow portion. If we hit run, it's going to update the output, which is in green. Okay, so here we go. We're going to execute that task. You can see it's currently busy with the slope. And once it has gone through this, it will then go and give the output to the slope underscore DEM1 value. Now, what is the benefit of this? So while that is processing, once this is computing and it gives you an output or an answer here, this can then be taken or translated into maybe a reclassification, which is normally done quite a bit, and you can then leverage that same reclassified data into a further analysis. So let me just skip a little bit here because it's still processing. Again, the more data you have, it could take a bit longer. And this is what I was talking about, reclassify. So we drag and drop it in here, and I want this data to be reclassified in here. Take that, and I'm going to have a certain output that I want, which is going to be the slope classification, or what was derived from the initial slope data, which was derived from the digital elevation model. So just bear with me, just follow the methodology again. Don't worry about the actual click or technical aspect. Understand what we are doing. Once you understand that, you're going to see the power of this actual workflow. So here we are. I'm going to leverage that, and I want it. You can actually change this value to either type or whichever field you would like. Maybe we can stretch that up a bit, and we can actually reclassify it if needed. Now, I'm going to make it according to ranges. So if you use Map 3D or even Civil 3D, sometimes when you run an analysis, it'll ask you for the number of ranges. This is more or less the same thing. From Esri's point of view, it's a common analytic tool that's used in our fields. Okay, so we've got that. We've got it by ranges, and as you can see now, it has added that for us. Now, just to make this a bit more cleaner, we will just kind of rename it a bit to say that it has been reclassed, it has been done. Okay, so if you have to share this with someone, they know exactly what they're looking at. So we've got that slope done and dusted. Now we're going to add more and more features from here. Now the very important thing is what we call an overlay. And this is actually a very powerful function. where we could take a weighted approach in considering multiple factors, pooling it together, assigning an importance to it in terms of percentage, and then deducing a value that is going to be more beneficial to us. So this is exactly what we're doing here, and this is where we are. Now, once we've added the weighted overlay, we're going to incorporate land use or parcel parameters in here per land value, meaning we will create ranges, let's say 1 to 10, 10 being the most expensive area or land use, and 1 being the lowest. Okay, we can assign different values to different areas, and then the software will take that or keep that in cognizant and bring it together in the analysis, right? So let's have a look here. So this is what we have. You can see those are the reclassified slopes, and we're going to be linking it to the urban data. Now, in order to do this, you would need to create a polygon from raster type of thing. Okay, so if you didn't pick that up, or if something's not picking up, for example, if I go to the master tab or the map tab, we would need to convert that using a polygon option. Now, where do we find that? So let's go here, polygon to raster. This is where we can identify the details that we want that's linked to the metadata. So land use map, and now we can just bring in one of the fields. So if you did an object table before, that is the same thing in GIS. The object tables are from GIS anyway, and we're going to take that and relink it. Now, I can also change the file path. I can also change the labeling methodology if needed. So you can see output raster dataset, and once we have that, it will export this. So let me just skip forward while it does that. It will incorporate all of this land use data you're seeing on the left. Now, you can see here we brought it in, and currently reclassified slope in terms of importance is rated as 100%. Now we need to change this. So let's say, for example, we want to consider the slope 40% imperative, and we're going to make 60% more attributed to the cost of the land or the land used for raster design. Okay, so let's go there. Now, first of all, whatever parameters you have here, it has to add to 100%. Otherwise, you're going to get normally an error. Now, you're going to see that in a bit. Okay, so we've got 100 there, and we can edit that value. It is not locked in stone. I simply have to just double click it, and I'm going to change it to 40. Okay, so let's go with 40, and land use in terms of data. So you can see already it's giving you a red X next to weighted overlay table because it wasn't adding up to 100. But now if I click, that goes away. So we've got that, and now I can also assign a value. So we've got our values here on the right hand side, where that is the classification, and this is the scale, meaning what classification do you want to use? What type of value do you want to read here? And what expense, if I could put it, do you want to link it to? So if we switch that value to type, again, we're reading off the object data table or object parameters that are prevalent in the metadata in the GIS field. We're going to take that, and this is the result. Now I can go and customize it. I can say maybe the barrack is rated at 1 in terms of expense or value, and I can go and edit it dependingly on whichever ones I want or feel are of most land value. So I will just skip through this fairly quickly because it's repetitive again. But as you can see, I can go and say actually the bridge is up at a 10 value. So I can customize these values accordingly depending on the informed decisions that I have. Normally you will get that in a schema report if you go through it, or if you have a nice urban planner who will actually advise you on this. Okay, so that's literally what we've done here, and we have incorporated all of those planning or parcels in here, and that is the result. So once you set all of those classifications, which one is the most expensive, which one is the least, and so on, you can see it will give you a weighted overlay based on multiple factors determined from below, and it will give you an optimal or best fit type of scenario. I don't know which other way to kind of get the message across, but I hope that you're understanding it there on your end. And of course, everything is related to cost. Now, Once we have the cost factor linked in, we need to decide which parameter we're going to use, which is going to be the most feasible route option based by distance. So generally, what we have here is we have the origin point, we have the destination point of the road, and we want the software to take into consideration all of the factors that we have predefined previously, as I've shown you, and we want it to be relative to the shortest distance between those 2 points. I'm getting quite a bit tongue-tied today, so I do apologize, but let's get into it here. Okay, so you can see again, I'm dragging cost distance parameter in here. Repetitive, it's the exact same thing we've done for the slope, for reclassify and weighted overlay, and this is now what we are going to do. So we've got all of this data in here. Again, if I double click on here, I will be able to customize it accordingly. So in a nutshell, we're going to create one for the origin point and one for the destination point. So let's go with destination this time first, and we are going to be linking, let's see here, the cost, of course, and we can actually determine the output distance in terms of raster, where it's going to be saved, those type of things. So just to explain what happened here, we took the destination point, we linked it to a cost, we created like a node. If I could use a simple term, it could be the wrong one, but that's literally what it is. We created a block there, and you can see we're going to be linking it to the backlink of that cost. Now we've got that. We're going to be also doing it to the origin point. So also it'll tell you, for example, if you have the same names, which is quite cool, so you don't create a duplication. Okay, so I will just rename that. Again, I'm just skipping through this because that is quite slow. So you can see it says cost, distance, destination. So you can rename it so it makes more sense to you, but you need to understand what methodology we're doing. Now we're going to add another one here, and this is to define the origin point. So have a look. Okay, so if I go and click there, let's go a bit fun, right? Actually, let's do maybe the destination. You can see sometimes it'll tell you that the feature does not exist, or you might have a red X depending on what you're trying to filter out. So it also guides you in terms of what you have available. So we had the origin that was already done previously. So again, it helps you to check your work as you're going along. Now we've got the object ID, which we want to derive from, and we're now going to just identify or derive the destination point. Once we have that, you can see origin point, destination point. We're going to bring in that cost using a weighted overlay into a final cost path analysis, and it's going to be showing us the final proposed path. And if I hit auto layouts, you'll see that it looks very, very neat. Okay, so from the weighted, we took it, we incorporated the costing, and then from there, we did a final cost part as a weighted type of approach. And now you can see, once we hit run, it is going to give me the proposed path that we should be considering based on all of these parameters before us. Okay, so I will just skip ahead quickly while it's running its analysis in the back. And this is where we go. Now we'll switch back to the map interface. You can see there is our origin and destination points as we load the map. Again, I can go and key in the values, or I can switch on certain things off and on just to check that, or I can analyze the data much more better. You can see all of those links are also under my databases now, which is quite cool for me to reference, and I can add that data or pull it into my current map view. So it'll take a few seconds to load, and if I toggle off certain data, it will be able to highlight the route that it does propose. So for example, let's maybe toggle off land use. That should help. Let's give it a few seconds, and maybe let's scroll. Here we go. Okay, so we've just switched off the map use, and if I go and have a look, this is the proposed path that it is giving me. All right, again, we did not draw anything. We use information to derive an intelligent path, or what we would call data-driven design. Okay, so there's the path and we are good to go. So we've got our most feasible option. The last one is to publish it to ArcGIS Online. So we've been doing it currently on Arcgis Pro. Now, all we've got to do is publish it online, meaning we need to go and select the data where it is saved on our desktop, so you can see from computer. So we will go and select that raw file. So you can see there it is. We can go and open it. We can decide what the contents are if needed. And also we can add tags. Tags are quite handy, especially if you're doing a lot of work with a lot of different people. You can see currently it says no existing tags. But what we can do is we can always add them. So we will tag them, and then of course once we're done we would hit add item and it will upload it and it will say published. That's about it. So now it is available on ArcGIS Online. Again, if you have any questions, please fire away in the text box. If there's something that did not come across clear on the GIS part, please drop it down, fire away. I will attend to it at the end, because that typically is the newest part for the audience. So now we're going to look at the planning and concept stage and how we can use BIM and link the GIS data to it. So let's look at modeling in context, meaning that we first need to switch to, in this case, InfraWorks, where we would create a contextual model. If you watch my previous webinars, again, I've done quite a few models here based in South Africa, and it worked out really, really well, pretty cool. So again, you would define the area, you can set your area of interest or the size depending on either your viewport, or you could actually crop it depending on what you want. This model is about 8.77 square kilometers, which is a decent size model. We can then link it to our organizations, and we can hit OK. The model builder will start building. And once it is done, we will then receive an email from Autodesk to say, hey, your model is done. We open it in InfraWorks, and this is the result. I mean, just look at that. That is fantastic. That is proper contextualized modeling. And you can actually make very informed decisions, and you can get public participation, client buy-in, and understanding of all those that are involved. So we've created the model of a road. Now, how would you link the GIS data to the site that we've actually created? So our BIM civil infrastructure model, how do we link that GIS data? Pretty simple. So this is the same connector that's built into Civil 3D and InfraWorks at the moment, but let's have a look at it. So here we are. Let's say this is our site. We've got a nice trumpet config there for the interchange. Right. Once we do that, what we'll do is we'll go to the connector. So this is fairly not that new, but it's recent. Okay, where we've got an ArcGIS Autodesk connector that links in now with InfraWorks and Civil 3D. Okay. So it'll give it a few seconds, and if your model is geolocated, what it should be, please geolocate your model, guys, so that it becomes out quite accurate and to the T. Now, once it is geolocated, it will automatically sync with your GIS platform or your ArcGIS Online platform. And you can see it has picked up the area that we are looking at, and we can now go and link in the data. So if you had any private content that you created, it will be under your My Content tab. If you're part of a group that had content, you'll also have it, or same with the organization. Or if you are lucky, you can go and leverage off public data, and if there is accurate data and it's freely available to you, you can incorporate that into your design. Just bear in mind, or very important disclaimer, is to see when last that data has been updated. You can always interrogate the data online to see when last it was updated. If it was like in 2019 or stuff, just use it with caution more than anything else. Okay, so we can go and search different types of data. We can search by area, and depending on what we want, the asset cards will pop up where we can tick exactly what data we want. Now, if you don't have access to data, you can use a live atlas, where hopefully again you could find some public free data. However, if you don't, you will need to reach out to a GIS provider that can help you to link into a portal or something like that. Okay. So as you can see here, we found some data and we can actually decide what feature type we want to bring in from here. So for example, buildings, we can select whatever feature we want. We've had two different types of buildings here classified in that area, but for representation purposes, we don't mind, and we will bring in whatever we would like. So you can see it even picks up the rail. If you have rail infrastructure within that area, everything is defined, and all I've got to do is say add to my design project. Now, once we do add it to our design project, it will be now live in our InfraWorks model. Okay, so let's go and see. All right, so once it comes in, it will sync in with your model builder in InfraWorks and everything will be there. So let's go and look at now how we can see it in action. As you can see already on the snapshot, we've got already the parcels and all of that information coming in from Arcgis Online, and we've also superimposed our layout on InfraWorks so that we can plot in much better. So let's have a look here. So this is the layout that we created. Okay, that's the PDF layout. We superimpose that onto our CAD model or InfraWorks model, right? A lot of people don't make or leverage this functionality. If it helps you, use it. If not, don't use it. It's there. And as you can see now, we're using the intelligent road design tools in InfraWorks to create the road geometry or the alignment. As you can see, it's very, very interactive or dynamic, meaning that it will update instantaneously as you make the design changes. And this is just a fast blitz through of it. And this is what you are capable of doing. You've got the medians, you've got the curves, you've got the lane markings, you've got the sidewalks, as well as the gradings that are assigned to the banking or daylights of your roadway. Okay, very fantastic, very, very awesome visual aspects or elements in there. Also, in terms of safety and design intelligence, we could size it according to various standards of transportation, as you've seen there. And we also got an option called corridor or profile optimization. This will help you optimize your profile relative to certain factors that you will incorporate in InfraWorks, and it will give you a full detailed report on how your design is going to look along. So again, all of this at a preliminary / planning phase stage is remarkable. It's going to make your life going into the detail phase much more easier. As you can see, you could actually toggle through your road. If you had super elevation and stuff, you could actually see the change in cross section. And not only that, we can then compute the materials for this roadway. Okay, we can also do traffic simulation, where you could actually select a defined area within your road or intersection or something like that. You can set your parameters, hit run simulation, and you could actually zoom in and have a look at what's going on. Of course, you can customize like the delays, the pauses, those type of things. There is a separate interface for that if you want to go in real detail, but you can see the benefits already at this stage. Now, once we have it there, we can actually bring it in for some prelim design, where we can actually generate drawings and stuff like that into Civil 3D. So there's zero waste of data here. You can see the transitioning from concept or feasibility stage right up to prelim now, which you're looking at. There's been a zero loss of data. You didn't have to start from zero anywhere in your design. Okay, so let's look at the drainage portion. How does BIM work for drainage design? Yes, InfraWorks does have a drainage design function that you can utilize. We recommend here in South Africa that you do it and bring it into Civil 3D, and with the conjunction of Geotech IDAS, you can finalize your final design. But if you're used to using hydrology methods, runoff coefficients, rainfall intensities, you're familiar with a bit of SSA, you can use this. So what we've done here is we generated a watershed, and now all we did was if the software analyzed it in the cloud, it gave me the flow downstream, and we positioned a culvert at that point. As you can see there, pretty good, right? So very insightful. It calculates all of the required dimensions, and we can also link in our own demand if needed, and that is the result. Okay, so if you are doing that, by all means, you can go and check that. You can see it even gives you your energy grade line, your hydraulic grade line, as well as your obvert to pipe. Okay, so all of this data is available to you using cloud computing and InfraWorks. And it also gives you the quantities, the number of inlets, manholes, pipelines, and so on. So very, very intelligent and still at the planning / prelim stages. And if we had to bring that or transition it into preliminary design proper, where we had to get or derive drawings, it links directly to Civil 3D and it comes through with all of its part metadata. So, I mean, all of that in this workflow is a real value add already, and with reliable data as GIS informing it, I mean, there's very little margin for error. Okay, so again, we've done that. We've added culverts. We can also add stormwater pipe networks along the road if needed, and so on like that. Okay, so let's look at bridge design. So since we are dealing with transport, these are anything or possibilities within the prelim stage or feasibility to prelim stage, and I thought it would be pretty cool to showcase it. So all we're going to do here is define the extent of the roads and take it from there. It will convert it to a first guess of bridge design, and then we will add it to the columns and those type of things. You can see that the pier also is linked dynamically to the alignment. And the cool thing with this, with the 2022 feature, is you can link in your structural bridge in conjunction with your alignment, in conjunction with InfraWorks, in conjunction with Inventor. So it's very, very connected. Speaking of Inventor, you can see it on your screen right now, where you can create parametric tools or elements of infrastructure and link it in directly to InfraWorks. And this fits in perfectly with the new proposed workflow between InfraWorks, Revit, and Civil 3D, connecting the bridge alignment or road geometry to the bridge structure itself. We can also create what we call or run a line girder analysis, which will do cloud computing for us depending on the standard that we select that's available. And this is a sample of what the report will be. Now, this will be accessible to you, okay? So you can actually check as a structural engineer what's going on, whether it looks cool, how's your forces acting, deflection, shear force, bending moments, all of those type of things that you would normally consider and take it from there. Okay, and that is it when it's brought into Revit. So this makes it easy because now if you do the geometry in InfraWorks and you bring it in here, all you're going to do is the rebar or structural detailing, which is pretty awesome. The last one I would show you from a design perspective is BIM for tunnel design. I don't think this has made a lot of noise in the market as I would want it to. So I wanted to show you how amazing this tool is. So here we've got a long section profile, again in InfraWorks. And what we're going to do is we're going to insert a tunnel starting there and ending there. And as you saw previously, the vertical profile was below ground quite a bit. And let's see what happened. How amazing is this? I mean, it's going below ground. We can change the config of the actual tunnel. It gives us the quantities. We can also create parametric other configurations for that tunnel, either in Inventor or whatever, and bring it in. As you can see, you have optioneering in front of you, visual optioneering, to decide which type of tunnel you would like to use. And you can actually increase the width. All of the metadata is on the asset cards on the right hand side, and this is the result. I mean, come on, you have all of this in the same connected workflow, and it's just amazing. And again, zero loss of data, people. I mean, it's just amazing what you're looking at. So we've got last two segments, and then we will wrap it off. The first penultimate will be collaboration, working together wherever you are. And this is by using connected collaboration with Autodesk Docs, okay? It is now being branded as, or being a part of the Autodesk Construction Cloud, where we have made different pairings or offerings available, being BIM Collaborate or BIM Collaborate Pro. We've got Takeoff as well as Build. Okay. So this connects designers, project managers, constructors, managers, as well as regulatory agents or even clients on here because it is permission based. Now, I am more concentrated on the design teams. Okay, so I've got one short clip to actually summarize how this works. So I can bring in the road from the cloud using a data shortcut that's linked or set up to BIM 360 or Autodesk BIM Collaborate Pro. Okay, as you can see, I'm bringing this data in from the cloud. It's not from a desktop, it's not from a server, it's from the cloud, meaning that anyone can access this data or who has access or permissions to it, as you can see here on the screen, and they can leverage it in real time, see exactly what's happening. And you can see if it is busy, they will actually tell you that the file has been locked because maybe that person is actually busy with it. So again, I can link in that control file, and you can see this is quite a complex design already. I didn't take a normal one road. This is quite complex. And you can see there's various amounts of corridors, all of that, that's linked in from the cloud to your desktop application being Civil 3D here. This also works for XREFs, right? So the functionality is the same, it's just routes to the cloud, and of course with automatic versioning or version compare, you can actually see the difference between the previous version, like you see here using the slider, of how things are looking versus the previous version, and I can also go back to a previous design without losing any intelligence. I can also communicate certain changes. For example, here we're looking at the banking, so we can actually assign it to someone, give it a deadline, and that person will receive a push notification like what you see on your screen. Okay. In terms of layers and tracking comments and those type of things, you can see it always has a numbering, and again, we could do a drive-through in Civil 3D, or we can bring it back to InfraWorks for visualistic design. So that was a very, very quick fly through of the cloud connection. Last but not least, which is the, I would say, my favorite part of this, being of a realistic nature, working on technical projects and seeing your technical vision being designed or translated in such a visually awesome way is really cool. So let's have a look at what you can do when you use InfraWorks. You bring all that data, you collate it, you create a final model in InfraWorks, and with some video editing skill and maybe some free editing software, you can do something like this. So this is a fly through. Again, I did a webinar on this called Present Your Designs Brilliantly with Autodesk InfraWorks that shows you the basics of creating what we call a storyboard. So this is more or less functioning that using cameras and fly through parts. Now look at this. We could actually fly through, stop at a certain point of interest and overlay what we would think it would look like. Again, you could use different other tools for that, and you can link it into the video with just a little bit of editing. I mean, something this complex, especially this model that you're seeing on your screen right now, can you imagine looking at it just in 2D or using unreliable data from the start? Can you imagine the problems that you would have had? It would have been catastrophic. I'm not exaggerating, because if you do not have all of the links and the GIS data in here, you would literally make a lot of wrong decisions, and this is what this workflow is actually preventing. So I hope you're seeing the value as you're looking at this, right? And if you want to take it a step further, now this is more immersive, as it's called nowadays. Check this out. You could actually link it to your Oculus or your HTC, and you could actually use a teleport function and look at your model in 3D, augmented reality, right? So you can see the controllers are there. I tried this at the Construction Expo before COVID. It is so realistic. If you spin a bit too fast, you actually get dizzy. I mean, look at this person looking down. It's very realistic. It might not look as much on your screen right now, but when you're using the goggles, I mean, if you're looking down a damn wall that's that high, you're going to feel it, right? So again, you've got immersive design that also helps quite a bit for very, very insightful design optioneering. So that is it. We are on the final segment, on just the closing. So let's look at some of the key takeaways and how we can help you go onto this journey. I mean, I'm really lost for words today, which is bad. I apologize, but today's key takeaways are as follows. So first of all, please incorporate GIS. I mean, you've seen the value that it has brought to you right now, where you could create an analysis that is rule-based. You can incorporate a slope, costing, land value, create a weighted type of average, and apply it to the shorter distance between your origin and destination points. Now, once you've got that data in, that comes with the parcel data, all of the relative data to the site, you're going to bring that in, and then you can link it directly to your civil BIM model in InfraWorks, i.e. contextualized design. Then we can then leverage the BIM intelligent tools. So whether you're doing a road that has a bridge, if you have rail design, if you've got tunnels, drainage, I mean, transportation is covered. Not only that, but much more. Also, you could then utilize the power of cloud computing and cloud collaboration. Cloud collaboration to work from anywhere, being connected as you've seen there, and computing for analysis such as watershed, and line girder analysis. There's a lot of built-in functions, profile optimization, as well as traffic simulation. And last but not least, if you want to be fancy, which I really strongly recommend you do, portray your design intent in a highly visual, immersive, and realistic manner. And this is brought to you by the two leaders in their fields, Esri for GIS and Autodesk for building information modeling. So how can we help you? So we at Baker Bains, we believe in solving our customers' problems through digital transformation, helping them to design and make a better world. And these workflows that we present to you actually are a testament. So we bring this together using our own consulting methodology that's unique to us. It's called an I-Adopt methodology, where we can help you as a professional, as a design company, consulting firm. I mean, whichever field you fall in, we've got you. When it comes to adopting technology, implementing it, understanding it, if you want to work together on a project, all those type of things, we look at your people, process, your technology, and we facilitate positive change management. So that's why I say consulting is a very, very big part of our processes. If you want to get in touch with us as Baker Bains, those are all our handles: LinkedIn, Facebook, Twitter, Instagram, and YouTube. This will be uploaded to our Baker Bains YouTube channel, where all of our webinars events are uploaded. So if you know a buddy that has missed it, I've got a slide after this to tell you where to find it. And of course, we have a Baker Bains support desk that is available to all of our clients from Monday to Friday, open at 8 a.m. right up to 11:30 at night. Very, very comprehensive, so our clients have that benefit. And our offices are in Joburg, where I'm broadcasting to you from right now, and as well as Cape Town, which I was probably last week ago. Yeah. Okay. If you wanted to reach out to me directly, anything civil infrastructure design, you can hit me up. My Autodesk primary focus is in the civil infrastructure industry, so mostly transportation based. However, if you want to look at it in products, those are the main ones: InfraWorks, Civil 3D, vehicle tracking, Autodesk, cloud applications, Recap Pro, laser scanning, and secondary, if you're going more vertical construction, I do play around a little bit with Revit, Navisworks for simulation, 3ds Max for visualization, advanced steel detailing, Inventor for parametric modeling. I mean, there's quite a bit. So if I can't help you, and if I'm not that jacked up in that spaces, we've got other professionals here in the architectural space, in the manufacturing, mechanical space, that are much more clued up in those packages, and I could gladly refer you to them. Other focuses, again, IDAS, if you haven't checked it out, please go and check it out. Especially if you're in the civil design space, go and check it out. It's a game changer for your civil infrastructure design. Reality capture, I play with a lot of fancy, cool toys, as I call them. Leica for interior, the GLS 2000 for site, and of course, VR applications like Oculus and stuff like that. Edgewise and Clear Edge related to both of these scanning applications. CAD learning for designer, definitely learning on the go and upskilling for yourself. If you want to get in contact with me directly, that's my email. Hit me up. Let me know what you think of the webinars, maybe what you want to see in the future, or what you're struggling with. Maybe if you're working on something cool, let me know as well. You can also find me on LinkedIn. I'm very, very active on there. And how I can help you as an individual, as a professional, I can help you with training, whether it be on the generic courses or on customized needs to your project based, or we can actually do a pilot project together, as well as scan to BIM, consulting, presenting. If you have any events or you want any representation or you want to pitch this to your teams, contact us. We can definitely propose that and present on your behalf. And last but not least, webinars, and of course kicking back and having a chat every now and then. It's good to hear what professionals are doing out in the industry. All right, again, all of the webinars are going to be uploaded to our YouTube channel. I will post the recording on LinkedIn with the link. If you do see it and you know a buddy that has missed out today, you get more than welcome to tag them in the comments and tell them next time that if they do register and unfortunately cannot attend, they will receive a link to the recording if they do register. Okay, so very important to register. And of course, if you subscribe to our YouTube channel and turn on notifications, you will be notified immediately when the recording has been uploaded. Okay, I think that is a ton of talking for me, especially on a Friday today. So I'm going to open up the floor for Q&A, and let me know what you think of this. If you don't have any questions, maybe let me know what you think of this workflow. Do you think it'll work for you? I mean, anything like that, while I browse through whatever questions have come through in the chat box. Okay, so please don't feel shy. I can see there's quite a lot of you on here today. So maybe hit me up, let me know what you thought of it. Or if you have any questions related to the topic at hand, please use the chat box. It is anonymous, so I'm not going to name call you, right? Let me know what you think. Okay, so I see there is a question here. Can environmentally sensitive areas be delineated? Right? 100%, right? So you can do that in GIS, and you can also do it when you're doing the corridor optimization in InfraWorks. So what you would tell the software is that these areas, let's say maybe wetlands you would need to avoid, or maybe there's some invasive or some historically type of endangered species of plant or something like that, that you are not allowed to traverse through, you cannot put a road through there. You can define that in the software. So the software now will route its routes, sounds weird, around these type of areas. So good question there. Again, it can be done in GIS as well as, or let me use the correct word, Arcgis Pro or InfraWorks, right? So definitely you can create avoidance areas, set your start and origin and destination point, and it will make sure that it bypasses that areas. Thank you for that. Okay, we have people saying it was a very nice workflow. It will help in an efficient design. Thank you. As I said, you will be biased on my end at the end of it. If you apply logic to it, it's a very, very informed type of workflow. Okay, any other questions? Let me just have a scroll. Okay, there's one here from with regards to InfraWorks. What is the difference between corridor optimization versus profile optimization? Okay, I get this question quite a bit, especially when we do training. Corridor is the road in its entirety. So you've got the lanes, you've got the curving, you've got the banking, you've got the profile, everything. Okay, it will just balance it in terms of the entire road as an entity, whereas the profile will look at it as the vertical alignment. Okay, so it will balance the vertical alignment in terms of cut and fill and so on like that. So I hope that makes a bit sense. If it didn't, you're more than welcome to drop me an email or consult the help file that's built into InfraWorks, as well as a lot of help resources on Autodesk Knowledge Network. Okay, I think that is it. I do not see any other questions here. Let me do one more scroll. I think I probably information overloaded you guys for Friday, especially before a long weekend here in South Africa. But you can always go and revisit this webinar just to sink in what we thought about. So with that, I would like to say thank you very much. Let's see. Thank you. Okay, I thought there was another question, another great comment, quite an insightful webinar. Thank you very much. I'm gonna give it a few more seconds. Are there any other questions? If nothing comes in this few seconds, I'm gonna wrap it up. Okay, I think we should call it. It has been a long one. So thank you very much for all of you that have attended. I hope this has opened your mind to incorporating GIS into your actual designs, into your process to make much more informed, reliable, accurate decisions. Because the data that comes in from GIS, depending on which data source you use or who is the provider, it is the up-to-date data which is an accurate representation of the site and its surroundings. So thank you very much. Have an awesome Friday, have an awesome weekend, and I shall see you guys here soon for my next webinar. Have a great day, everyone.